Yeah, good morning to one and all person here. Today we discuss what are the different types of data structures. Okay, first one is a list. It is a linear data structures. A list can be defined as a collection of variable number of data items. It is a linear linked list. It can be defined as a collection of variable number of data items. An element of list must contain at least two fields. One for storing data or information, and other for storing address of the next element. As of you know, for storing address, we have a special data structures of list. Address must be a pointer type. Here pointer type is used for the storing address of the next elements. Okay. Finally, a list is a linear operation of the data structures. It is known as here. Technically, each such element is referred to as a node. Therefore, a list can be defined as a collection of nodes. Here is a simple example for the arrangement of list. Here, first node is a head node. Second one is a AAA represents the information. It points to the address of the next node. Okay. Here, a node contains two fields. One is the storing address. Another one is the data information. Finally, last node is nothing but a null node. Okay, what are the different types of data linked list? First one is a single linked list, double linked list, a single circle linked list, double circle links. Here in detail about next class. Okay, next one is a stack. A stack is also an ordered collection of elements like arrays, but it has a special feature that deletion and insertion of elements can be done only from one end. That is called as a top of the stacks. Insertion and deletion can be operated to the only one end of the stack. That is called as a top of the stack. Due to this property, it is also called as an either last in first out or first in last out. Next, it would be throw of just it would be thorough of just like a stack of plates placed in a table in a party. Best example is a stack of plates placed on table in a party. A guest always takes off a fresh plate from top, and the new plates are placed on to the stack at the top. Okay. Either insertion of plates and the new plates are placed in the top of the stack. It is a non-primitive data structure. When an element is inserted into a stack or removed from the stack, its base remains fixed where the top of the stack changes. Okay. Either insertion or deletion, it base is remains fixed where the top of stack changes. Next, insertion element is called as a push, and the deletion element is stack is called as a pop. The figure shows the insertion deletion at one end, that is called as a top of the either push operation or pop operation. Okay, it contains only one place, that is called as a top of the stack. Okay, how are you going to implement this type? That is a two types of implementation. One is using arrays, that is called as a static implementation. Another is using pointer, that is a dynamic implementations. Next is a queue. This is the best example is either reservation, either a railway ticket reservation or cinema theater ticket reservation. It's the best example for the queue. It is a first in, first out type of data sources. That is FIFO. Either last in, last out. Okay. Mainly consider either first in, first or last in, first out. In a queue, new elements are ordered to the queue from one end. It's called as an rear end, and the element are always removed from the other end called as the front end. Okay, in queue having two ends, that is a rear end only for insertion operation, front end is called as a deletion operation. The people standing in railway reservation row are an example of the queue. Each new person comes and stands at the end of the row, and person getting the reservation confirmed get out of the row from the front end. Okay, here element is arranged in, it is a linear. That is the first one is a 10, 20, 30, 40, 50. Okay, here 50 is a rear end, 10 is a front end. Okay, how we are going to implement the queue is using arrays, then using pointers. That is the arrays known all of the static implementation. Point is always known as a dynamic implementation. Next one is a tree. A tree can be defined as a finite set of data items that is called as a nodes. A tree is a linear type of data structure in which data items are arranged or stored in a sorted sequence. Okay. It is a linear type of data structures in which data items are arranged or stored in a sorted sequence manner. Okay. Tree represents the hierarchy relation between various elements. In a tree, there is a special data item at the top of hierarchy called the root of the tree. All of you know this a tree is a root node, then left child, then right child. The remaining data items are partitioned into number of mutually exclusive subsets. Okay. Each of which each of which is itself a tree, which is called as the subtree. First node is called as the root of the tree. The remaining data items are partitioned into number of mutually exclusive subset, each of which is itself a tree, which is called as the subtree. A tree always grows in length towards bottom in data structures, unlike natural trees, which grows upwards. Here is the organization of the data. That is a tree structures. Here A represents the root node. Here remaining all our nodes are the leaves nodes. Here A is the left child of the B. C is the left child of A. Then again subtrees. This is the organizations. Next one is the graph. It is a mathematical non-linear data structure capable of representing many kind of physical structures. Okay. It has found application in geography, chemistry, and engineering sciences. Next, what is the definition of graph? A graph G in open bracket V, comma is a set of V represents set of vertices V and set of edges. A graph G is a set of vertices and set of edges. Graph. An edge connects a pair of vertices, and many have weight such as a length, cost, and another measuring instrument for according to the graph. Okay. An edge connects a pair of vertices, and many have weight such as length, cost, and another measuring instrument for according to the graph. Okay. Vertices on the graph are shown in point or circles, and edges are drawn as arcs or line segments. Okay, either connect between the vertices using a point or circles, and the edges are drawn as a arcs on line segments. Here the example for the graph. Okay, here V1, V2, V3, V4, V5 all are vertices. Here 10, 15, 8, 9, 11 all are that is edges are weighted. Okay, that is called first diagram is shows that the is a directed graph. Second one is a V1, V2, V3 for all as a indirected graph. What are the types of graph? Directed graph, undirected graph, simple graph, weighted graph, connected graph, and finally non-connected graph. Okay, these are the types of the graphs. Here today we discuss about what is list, what is stack, what is queue, what is tree, what is graph. Okay, remaining see in the next class. Thank you.